Stars so bright in the sky. On Arizona nights they fly. Nebulae in colors rare. Galaxies beyond compare. Sky tour in the night so clear. Brings the universe near. Real-time wonders to see. Streaming light for you and me. Lift your eyes to the skies, universe in all its light. Sky tours bringing the views. Every night feels brand new. In the dark, the night unfolds. Stories of the cosmos told. Through the lens, a distant dream. Living real like a gleam. Far away, up so high. Across the stars beyond the skull. Through the lens, a distant dream. Living real like a gleam. Lift your eye up so high. Across the stars beyond the sky. Sky tour shows us the way. Every night a new display. Lift your eyes to the skies, universe in all its light. Sky tours bringing the views. Every night feels brand new. Lift your eyes to the skies, universe in all its light. Sky tours bringing the views. Every night feels brand new.
Hello, everybody. Welcome to SkyTour Livestream, Night 2 of the Comet, Night of the Comet. And I'm here with Daryl Mason, as always. Hello there, Daryl. How are you?
Oh, Mark, I'm good. You?
All right.
Hi, everybody.
Yeah, we're doing good.
I don't know about the comet so much.
Well, we have clouds right now, guys, and it's sunset out there, so you can see on the screen, you can see the sky is, we have clouds passing by. This is a half a second exposure. So we can actually go to, say, 250 milliseconds, which is a quarter second, and see how that looks. Might saturate the colors a little more. Let's do this. Yeah, there we go. See, now it looks like a nebula. It's actually the red of sunset. And you're seeing how bright the comet's tail is. You can see it through the light clouds. See that? That's pretty cool. There have been a lot of photos of this comet taken by many people around the world. One particular guy took this amazing image of the comet's nucleus, which we don't have the focal length to do that, meaning the magnification capability with our telescope. So we can't take that kind of picture. With the new Celestron 11, however, we'll have a better chance of doing something like that, because it's going to be really, really something. I want to acknowledge, of course, that this comet that we're seeing here, this is Tsuchinshan-ATLAS, and it's not Comet Atlas, it's not Comet A3, it's Tsuchinshan-ATLAS.
You know, I heard that it's Tsuchinshan.
You know, it depends on the dialect of Chinese, and that could be correct depending on where you go. I worked with people that spoke, Mandarin, and Cantonese was different, and people from that speak Mandarin cannot understand the people who speak Cantonese, and they have different ways of pronouncing it. And this woman's name was TSU, and then the rest of her name, and I said, "Oh, how do you pronounce it?" And she says, "It's Tsu." Tsu, not Sue, but Tsu. So you actually say the T. So that's why I say that. Maybe it's a dialect thing.
Excuses.
No, not at all.
Go to a Chinese restaurant and try to order a Qingdao beer. Most people will say, Tsung Tao.
Well, it depends on, again, the dialect that the people at the restaurant speak.
Yeah.
And they have attitudes about it, by the way, as I discovered.
Oh, I bet they do.
Yeah, they do. So here we got, guys. We got some clouds passing over. It's supposed to get cloudier later, but
I'm from southern China.
oh, okay. I see what's going on here. Shouldn't be a problem here. Let me go in, and you'll see all these new cool things here. Let's go to our system. This is our all sky camera. All right, and we're gonna stop it. We're gonna stop it and start it again. It might be right in the middle of it might be right in the middle of it doing the cut over to nighttime, actually. So that might be what's doing it. So I should have maybe just let it go for a while. On our live view, it's gonna say all sky is not running, and then it's gonna say it's running because I started. Yeah, there we go. So it's starting up. All right, we'll come back to that in a minute. So we'll get to see what the clouds look like. We're gonna go as long as we can, but you'll see the clouds passing over. It's actually not that many clouds. It's just it's strange. I'm hoping this doesn't take us out of the running for tonight. There's no precipitation now in these clouds, and that's fine. Looks like the comet's racing through the sky, though, doesn't it?
Kinda. You know something? I'm just making an observation here while we're waiting for the clouds. It's interesting to see how traditional, old school some cultures still are. Speaking of the Chinese, I love Chinese food. I don't eat it very often. At the Chinese restaurants in my part of town, they all change hands on a occasional basis, and they always sell within the Chinese community, and I suspect a lot of them are immigrants, because the faces change, but they're always Chinese folks. And it's always a mom, a pop, and a dutiful young son or daughter. And the son runs the front counter, or the daughter, and mom and or dad are cooking, and whichever one isn't cooking is waiting tables.
It must be a family affair, huh?
Oh yeah.
Okay, let's see. I don't know that this was able to get it because of the clouds. It has to try and guide on it, and it can't guide. So, yeah, that's what I thought. We're going to end up with a lot of the sunset light in this first set of images. Well, that's kind of cool. Look at that. Let's level that out. Let's do this. Let's do this.
Trippy, man.
Yeah, it is trippy. It's kind of a...
That's pretty cool.
Making abstract art out of it. Check it out.
Yeah.
That's pretty cool. I'm going to save that. That's kind of neat.
Dave's not here, man.
Yeah, I'm sorry, man. Dave's not here, man. Wasn't that Tommy Chong?
It's Cheech and Chong.
Yeah, Tommy Chong said that, though, right? Or was that Cheech? Cheech Marin.
I have no idea which one said it. It's been too long.
Yeah.
Good God, that was 50 years ago.
Dave's not here, man. No, wait.
It was the Big Bamboo album, if I remember correctly.
Yeah.
But cool picture all the same.
Yeah.
Like a fever dream.
I'm going to save it anyway, even though I don't have it written out. So it's going to save it just to our generic location. Izabela, I apologize ahead of time for that.
Don Kunzer said it was Chong.
I thought it was Tommy Chong who said that.
Yeah, I guess he.
Yeah. Well, these clouds just popped in. I'm hoping they're going to go away because they weren't there before. So what I'll do is I'm gonna go check on my weather and see what I got going on there. That's interesting. Oh, I see. It's a patch. It is a patch of cloud coming through. I'm looking at the weather now.
Cleveland beat the Yankees tonight. Heck of an ending to the game.
All right.
It was like a 2-run walk-off homer at no, what was it? They had tied 5-5, and then bottom of the 10th or 11th,
Okay.
Cleveland had a walk-off home run to win the game.
Okay. This patch of clouds we're seeing is isolated, and although we can't see what's down here, this was a set of clouds that were actually deconstructing on their way northeast. And so, that said, this patch of cloud may actually go away. So I'm going to wait it out because the west is going to open up first. Yeah, if it doesn't, we will have to cut it short, but I don't want to because we got a really cool thing here. Well, not this, but let's try this now.
Not like comets are around every day, huh?
I know, that's the thing. I was hoping to see if we could see that anti-tail again today. Oh,
Yeah.
wait, what do we got here? Okay, this is a 5-second shot. Yeah, let's do this. Yeah, oh, I gotta get rid of this too. Hang on. There we go. Looks like a sonic boom, like a jet went through a sonic boom. There's a shockwave. I see a faint anti-tail there.
Yeah, you're right.
I see a little hint of blue here with the dust here. I'm not sure if that's the ion tail or just pollution from this stray light right now. That is actually a cloud in the way. So let's see if we can clear this. And actually this is a 5-second shot. So, okay, that's not so bad. Yeah, there's the anti-tail. Alright, so let's mess with the processing just a little. Again, it's sunset. I'm sorry, go ahead.
Kind of surprised the anti-tail's still around. We went through the Comet orbital plane a few days ago.
Oh, it must be a large fishtail hook on it. It must have swung way around. But it's right there. Kind of looks like it might end here. I only see it out to about here.
Oh, well, the sky's hardly clear right now.
Yeah, it's hardly dark enough too, you're right. Alrighty, well, you know, that's what happens. I want to say hi to everybody who's here. So, hi everybody that's here. Tiffany was first. Hi, Tiffany. I hope Mike is still around. I haven't heard from him in a long time. And we have PJC is here. Nice to see you. West, nice to see you, man. Alicia's here. Hi, Alicia. And Michael Hedrick, as always, nice to see you. Daisy and Zoe are here. And I also, and Izabela, hello. And Hein is with us. Hein Sherry, how are you? Daisy and Zoe. I want to just say, by the way, we're going to call this the birthday comic because today is my birthday. I am 97 years old. That's a total lie, sorry. So we're going to call this birthday comic. That's why I wanted to stream tonight. And I think it's going to be a good night. I'm going to see what our sky looks like. Okay, we're starting to see some breakup here. The moon is coming up, as you can tell. I could actually just come in here, and I think my settings are such that I've got the exposure set here for nighttime is an auto exposure. I'm going to turn that off. Oh, no, wait. No, I want it off. I'm going to take this down to 4 seconds to see if we can grab that horizon. I'll save these changes, and the all sky is going to restart. And
all sky.
Yeah.
I didn't recognize the program, the app.
Oh yeah. Okay. Also, I wanted to say hello to Michael Galea, who's joined us. Hello there. I want to thank you guys for the birthday witches. Witches. Thank you for the birthday witches and warlocks. Thank you for the birthday wishes, guys. That was very kind. Stuffy, how you doing? What's happening with you? Donald Kunzer's with us. Nice to see you all. Tiffany says it's been constantly cloudy here, so I haven't been able to see the comet for myself. Oh, I'm sorry to hear that. Sorry to hear that. Stuffy says hi to you, by the way.
Yes, I think I said hi back.
Okay. And Raul Babadia, how are you? Nice to see you. And down in Brooklyn, that's cool. And let's see, we've got Kathy Bernasek is with us. Hi, Kathy. That's X-Lady. We've known X-Lady for years. Kathy Messick, how are you? Nice to see you. I'm glad to have everybody come out for the Comet tonight. And hopefully we'll have some fun. And Susie Karasik, who I met. Susie's one of our winners. Okay, nice to see you here, Susie. I'll be seeing you again, I'm sure. And we have Giancarlo Belfry. That's nice to see you. Cosmic Flow's with us. So I'll just say this. For those wondering, because they're asking in the chat how old I am, I'm actually 64 years old.
Young.
Well, whatever. Yeah, I have a number 64 attached to my name. But it's actually
Young punk.
Right. Well, compared to some, maybe.
To some, yeah.
So there we go. Now we got our lighting that I wanted.
I'm older than Mark. I won't say how bad though. I'm retired.
Yeah. Tricia Ferrer's with us. Hey, Tricia.
Happy birthday, Mark.
Thank you very much. That's very kind. Yeah, so, what I get to do is I get to make dinner for everybody who's coming over to my house for my birthday. I get to cook. No one's cooking for me. I get to cook. It's all right. I like that. It's fun.
I will make an observation on the comet.
Please do.
The brightest part of the dust tail I see streaming toward the upper left, and the anti-tail dimly streaming toward the lower right, they were a pretty straight line last night. They no longer are.
Yeah, that's right.
Both are tipped down a little bit.
Yeah, this is at an angle.
And the brightest part of the dust tail is too. I kind of faintly see it right there, which is saying that we are well through the plane.
Yeah, and we're starting to get below it.
Yes. If you saw that cell phone image from a day or two ago, where the Soho Solar Observatory went through the plane of the comet.
Yeah.
The same thing happened. You saw it coming from above, and it passed right through where the sun was in the occlusion disk, and then it passed below it and went from top of the screen to the bottom of the screen and developed a bit of an angle, just like that.
Yep. All right, here's what I'm going to do. I'm going to clear this. I'm going to try to use our full width half maximum filter, which will filter to get the best sharpness in the stellar images. And we'll see if it's going to work. Well, we're still doing a 5-second shot right now, aren't we? Well, let's pull this up a little bit. This is going to be this will be fuzzy, I'm sure. Or not round. But we'll give it a try. It's still into, okay. Let me turn this off. I want to do more than 5 seconds though. And I want to increase. That line is still there. That must be a longitudinal cloud that's still in the way. I'm going to increase our gain here to 150 and clear this again. Try and capture this again. Okay, so there's the tail very clearly, and yeah, we're unable to guide right now because of the clouds that are passing through, so the guiding telescope cannot get a fix on any of the stars for a long enough time. Let me tweak this. And so when it says searching, it should actually start showing us numbers indicating that it's guiding. So I'm waiting for that. It may not come back if it can't catch the stars. Well, it started. So let's clear it. And try and do it just in 5 seconds, see what we're getting. There's one. Yeah, the second one is really high. Why is that? 12.16. Oh my. Yeah, it's unable to guide. Let's see if we increase our exposure. Let's do 1 second shots. And clear again. See if this will give us at 200 and okay, now it's 9.43, 9.53. Let's do this. Okay. Right, let me get out of this. Not out of it, but let me just do this one more time. Okay, 1 second. Exposure. There's the comet nucleus right there. Alright, there is that. And let's try 8 seconds. Alright. And let's go into our deep sky mode. It's hard when the sky is still light. This is like the earliest we've ever tried looking at the comet.
Okay, while the sun shines,
Okay, well this is working now, so let's
so to speak.
Yeah. Let's color correct. And let's correct for our processing here. There we go. Look at that. There's a nice tail, and there is our anti-tail at that slight downward angle. As Darrell pointed out before, we're through the plane of the comet's orbit, and we're like a little bit below the comet. Alright, so we darken this up a little bit. That's nice. Okay, that's 4 stack. Now I'll actually put it in here.
You mentioned seeing the nucleus of the comet. Was that those images I sent?
Yes.
That was really something.
Yeah.
It looked like close up. It looked like somebody had thrown a layer cake.
Yeah, and splattered it. It's literally an area this big.
Yeah, it had all sorts of layers and parabolas inside parabolas around and close to the nucleus. Very intricate looking.
Yeah. Now, if you're wondering what you're looking at, okay, let me just do it this way, because this way it will help. I'm going to move up in the shot here. In this nucleus, the dust tail comes out like this, and it's curling around, going into the page, okay, and showing up over here. This is the tail end of it. It's the end right here of this dust tail right here, curling around and coming back down here, far away. So that's what you're seeing here. It's a curved tail, and so that is what's called the anti-tail, because it appears like it's sticking out of the front of the comet. It's not. If you look at it from overhead, it would be a slope. It'd be a whirling tail that's swirling around, and kind of like almost in a round half circle going around the comet, because as it's going around the sun, the comet lags behind, and it gets into this mode where as it goes around the sun, it's fishtailing around the sun, and the end here that's sticking out, the comet's here, the end of the tail sticking out here. So from our perspective down there, looking this way, we're going to see the head of the comet and the tail sticking out, and that's what we're seeing right here. It's a three-dimensional effect. Let's check out our all sky.
It's a matter of perspective.
It is indeed. Okay, this is our view now. So as you can see, we're doing better. The comet, I will say, is right here. You can see it right there. As it gets darker, it'll become more obvious.
May I address Susie's question?
I didn't see her question, but yes, just read it so people know.
Right. So where is it going, and what is the meaning of the name? Susie, the comet passed the sun at its closest recently, and then it passed closest to Earth on the 12th. The comet is now heading back out into the Oort cloud, out in the far margins of the solar system. The comet has an 80,000-year orbit, so enjoy it while you can, because we're never going to see it again. The name is for the two parties that discovered the comet. Tsuchinshan is the Purple Mountain Observatory in China, Purple Mountain Observatory, who discovered the comet. It was simultaneously discovered by the ATLAS project, automated search program, and I forget what ATLAS stands for. Mark, do you recall offhand?
The ATLAS, it's named for an instrument, and I don't remember the actual acronym for the ATLAS.
Yeah, it's an automatic search program, but if I remember correctly, it's hunting for hazardous objects.
Yeah.
Like, near-Earth asteroids coming toward us, planetary defense sort of thing. And it just happened to pick up the comet. So, Tsuchinshan, Purple Mountain Observatory, and ATLAS Project got their names stuck on the comet.
And if you discover something, you can get your name stuck on the discovery as well. And the International Astronomical Union will probably grant that. As long as your name is not something crazy. But then again, Tsuchinshan is not the easiest thing to pronounce either.
And Trisha has a follow-up question. Can I ask a dumb question? No dumb questions, Trisha.
That's what we said.
Why don't comets burn out?
They do?
They do.
Yeah.
Occasionally. I mean, Halley's Comet is still going after many passages through the inner solar system. There are other comets which have burned out, and we don't see them as comets anymore. There's one that causes a meteor shower every early winter. What is it? Phaeton Comet? Sometimes they call it a rock comet. It's basically it's used up all the gas and water and volatile elements that were formerly in the comet, burned out by repeated passages through the sun, and what's left is a rock comet, or basically an asteroid.
That's right. The asteroid, a small asteroid, may form the core. Then ice is accumulated in the early solar system as the solar system was forming. And comets are among the oldest things in the universe, our universe, because when the solar system was formed, these were around 4.5 billion years ago. That's when they formed. So when we look at comets and we look at what they outgas, what they give off, that tells us a lot about what was in the early solar system when Earth was formed. So they are a direct view back 4.5 billion years at what was here in the solar system. That's why studying comets is so important. Okay, learning about the compounds that we're seeing here getting leached off. These are a lot of this is ices of all sorts. We have water ice, we have ammonia ice, methane ice, we have carbon monoxide, ammonia ices. We have all kinds of stuff. Cyanogen is a gas that is a carbon and a nitrogen atom together. CN, that's cyanogen. And that particular, along with carbon, that particular combination makes green glowing ions. So whenever you look at comets, sometimes they look green. And that's because you have the dust tail and then you have the ion tail. The ion tail is those compounds and ices I just told you about that are being ionized, meaning their electrons are being driven off the atoms. And when those electrons come back onto the atom, because they will, okay, then they give off light, and that light that they give off is a characteristic color. For cyanogen, it's green. For carbon compounds of some types, it's green. So that's why comets are generally green, because there's a lot of carbon on board, and carbon is the fourth most abundant element in the entire universe. Oxygen is the third most abundant, interestingly. So there's a lot of oxygen bound up in different compounds on these comets.
Carbon just entered the room.
Oh, did he? Oh, Carbon Star's here. Hey, how you doing? Yeah, he says, it's wild that some comets have orbits of millions of years. Oh, yeah. Well, if you think about it, this comet's moving around 640,000 kilometers an hour. And even at that speed, which is slow compared to light, it's going to take many, many millions of years for a comet, some comets that are way out in the outer reaches of the Oort cloud to get back in at those kinds of speeds. This comet, it's at 640,000 miles an hour because it's actually closer to us than the far reaches of the Oort cloud. It's going to be about 80,000 years or so, if I recall.
Yes. Robert E. Waters says ATLAS stands for Asteroid Terrestrial Impact Last Alert System.
Thank you for looking that up for us, Robert. Unless you work in the program, that'd be good to know, too.
I knew it was something like that.
Yeah, I couldn't remember all the details of that. All right, so here's I'm glad we were able to get this night. I was hoping we'd get it. We wanted to see this anti-tail again. I saved this. We have 57 shots here. This is only an 8-second shot. I'm going to try a little deeper shot, and I'm going to go to 250. So I'm going to save this. I'll show you what I mean, guys, in a minute. And now you see me saving exactly a scene, and then you see this bar. So this picture that I'm bringing up right now, just like this that you see, this is now being saved to our server. And our server is at skytourlive.org. You can go there and scroll down and say, take me to cool pictures. I want to see cool pictures. And that's what we do now. Soon we'll have our app up, and I keep saying that, but Izabela, who is in our chat, she is a super user and a super, I don't want to call her a fan, because that's she's not a super fan. She's a super partner with SkyTour Livestream. That's a better way. And she's written an application that goes back and looks at years of our data and allows you to look through our data and go see every time we look at a comet, for instance. Look up the word comet and find all the comets we've seen. It's really cool. And that app we're going to try and get available as soon as we can on Android, Mac, PC. Right now it works on the PC. It works on the iPhone. It probably works on Android devices. I don't know anyone that's actually for testing put it on there. And it'll certainly work on a Mac right now as long as you get the link right. So that's what we're doing. We're actually getting this data so you can get it easier. But in the interim, go to skytourlive.org, and if you want, you can donate to us to be helpful. Obviously, because we've got a lot of things going on. I'm going to tell you about some more in a minute. And then we also have a Patreon you can join. There's a $3 a month Patreon. There's a $5, $10, $25, $50, $100, $200. And believe it or not, we have people at most of those levels. Now, the interesting thing is, and we don't have a whole lot of patrons, and I'm actually going to put the list together and display it. I have some of them. I don't have the whole list. There's only like 25 patrons right now, Patreon members. We could use 100 Patreon members. It'd be great. With all the people we have watching, we're approaching 8,800 subscribers. So not the largest amount of subscribers, but this is basically free astronomy education. And there's no one doing this on the web like this. Nobody. I looked. Let me color correct this one more time. And let's save it. Now, as we're saving it, one thing you'll notice is that this nucleus is now getting extended. Why is that? Because it's actually moving. It's moving very fast. We can actually see this movement moment to moment to moment. So if we clear this right now, I'm actually going to come back now and make this a 12-second shot, 12,000 millisecond shot. Okay, and now we'll clear this. Okay, and now this next 12-second shot that we see, I said 12,000, but it didn't do it. Okay, there we go. No, yes. Okay, so you see it over here. So we'll clear this again. So no data here in our buffer, and we'll see it in just a minute. Hey Tim F, how you doing?
We noted in last night's images of the comet, if you see stars back there in the tail to the upper left of the nucleus, if you watch those closely over time, you will see those stars shift against the position of the tail.
Like right here. There's two right here. Okay, here's the nucleus. Okay. If we keep watching, you're going to see this nucleus getting closer to these stars. It's not going this way. I think it looks like it's going that way, but I don't believe it is. I think it's actually traveling this way, and it's traveling back around the sun, heading out. It's not like a jet streaming a plume of exhaust. The sun is forcing this stuff to go back like this. We have some more clouds, I see. Oh, this is funny. It looks like, for this satellite here, it looks like it's going behind the comet tail, which is silly. It's really not. I'm going to save that because that's a kind of a funny image. It actually just looks like that because there was a cloud there. That's what this is. There was a cloud that blocked the satellite trail. That's funny. It's proving the flat Earth guys. No, the satellites are really close to us. Or the other way around. Hey, Goblin. Cloverleaf's with us. Hi, Cloverleaf. How you doing? Cloverleaf says, bummer, I was trying to track from the St. Cloud area and then trying to go out, but it was too bright. Meaning the sun hadn't set yet. Okay.
Yeah, it's 9:14 in Minnesota now, and he says it's supposed to set at 9:20 something, so it's going to be too close to the horizon. 9:36.
Yeah, a single tree might block it. You might see the tail in binoculars. That's kind of an odd sight when the comet actually sets and the tail is sticking up. It's like, what's that? What it is proof the Earth isn't flat. If you tell all your friends. All right, let's clear this now.
Mm-hmm.
And we're gonna just take a quick look here on the all sky. Oh yeah, here we go.
Does look better than before.
Oh well, we just got that cloud bank popped in. There's the comet right there. All right. All right. Well, that's making it look a little strange, but let's minimize this here. Yeah, that's what I thought. So see, guys, we got some cool comet views that look a little strange tonight. What can I say? Alicia Vieira says it looks like a Pink Floyd album. It does. That's right. The Dark Side of the Comet. Or Cometary Void album. Cloverleaf says it was too bright because of the moon. Well, yeah, the moon is looking full, isn't it? So it is actually kind of difficult. Actually, phase of the moon, I can tell you exactly because we have it in here. Phase is 99.4. And I think that's on the way down. So as time goes on, meaning the week, we will be at the point where we will see a darker sky. This blue is from the moonlight that's infecting us here. We are using a special filter, but we still have sunset clouds. That's what these reds are. That's what they are. As dark as it looks here, it's actually not that dark out there. It's going to have a beautiful sunset clouds out there. Izabela says the anti-tail is so strange. It is. Let's see if we can get a clean view of it right now.
It's a natural phenomenon.
Oh. Oh. Well, there's your phenomenon. Yeah, we have that big cloud bank probably went over the top of it. Well, as you can see here, north, south, east, west, the western horizon is where it is. It's down in here, so it's going to be kind of tough to see with these clouds over it right now. Yeah. Well, I figured I'd give it a shot tonight, guys. Why not, right? Tried and tried and tried. But hey, that's what happens. It didn't prove fruitful.
Cloverleaf, there may indeed be two comets in October.
That's right.
C2023A3 Tsuchinshan-ATLAS is the big one, but they recently discovered another one on its way in that they don't know how good it's going to be yet, but there is another comet out there right now. They usually are, actually, but this one may become good enough to look at. That one may be good enough to look at.
Yeah.
I forget what it's called. Tiffany, count me out, please.
Oh, hey, we're doing a birthday giveaway, Tiff? Wow. Oh, how about that? I'm glad she finally told me. I just read the message. So see that, even though it's cloudy tonight, guys, we're giving away equipment tonight, thanks to Tiffany Echo and Michael Tarr, our two super patrons who give us equipment to give away. I think that's wonderful. Thank you so much, Tiffany. What a sweetheart. That's really cool. All right, so what are the rules, Tiff? Message me and give me the rules. Hey, Prow, I know clouds are bugging us out, yeah. Well, here's the rules. If whoever wins a pair of Celestron binoculars from us tonight, what I want to make sure you understand is that we're gonna need you to we're gonna need to get your information, and the way you can do that is go to skytourlive.org, all right, and go to the Contact Us section, and there's an email there, and you'll be able to connect with us, and you'll be able to actually give us all your information. So now I'm waiting to hear from Tiffany. She says something. She says a raffle style tonight. Or so are you taking down the names and you're gonna put them in a bin there, Tiffany, and you're gonna pull them? Is that the idea? Yeah, they're great, aren't they? That is fantastic. Thank you, Tiffany. Jesus, that's just fantastic. Oh, she is. She's actually... Okay, guys, see that? If you write in the chat, if you're watching but not typing in the chat, you can't win. So what you have to do is you gotta just write a comment in the chat, say, "Hi, I'm here," and you'll get an entry in our raffle tonight. All right? And you're gonna get a pair of beautiful Celestron binoculars that'll allow you to look at things like the comet. See, here's the thing. A pair of binoculars is your best friend when you're learning astronomy, because they open up so much more of the night sky. Your pupil is this big in diameter. It's tiny. It's a few millimeters across.
7 millimeters.
I was going to say, yes. But the binoculars are way larger, and they have a much bigger area that they can capture light. So I think that is cool. Donald, we're doing raffle style tonight, not a number. We usually do a number between 1 and 1,000, guys. And Donald, we're actually, just by having your name in here, you're getting an entry, and so your name is being entered. And Tiffany is going to draw it out as we come to a close, and I'll make the announcement. Then it's up to you, the winner, to go to skytourlive.org. And when you go to skytourlive.org, you'll be able to see exactly what you have to do. You're going to go to Contact Us, and you're going to write a message, say, "Hey, I want my binoculars that you promised me." You know, and that'll be that. So there is an email us on skytourlive.org. That email us is going to go right to me at ContactSkyTour@gmail.com. So I'm looking forward to that. All right. And see, Carbon Star says, "I remember watching Hale Bopp through binoculars in the 90s, and it was great, wasn't it?" It was great. Hey, Waldo. No, you actually, once you don't have to type nonsense. she's going through and she's getting all the names that are in the chat. Once your name is in, you're in. You don't have to keep typing, because the more you type, it's not like an additional entry. Oh, but we should do that someday, as long as we don't spam. But yeah, we can't do that. We would just go ding, 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 ding. Just keep entering. So, let's see here if I can. Yeah. All right. So what you're looking at here, this is our site. Okay, SkyTour live stream. Okay, and in the upper right here it says email us. Click that, and you can get to us. All right. And if you do call us, well, you're going to end up talking to me. All right, but which is fine. But this is our location, and it's a Universe Live in real time. And we put one of our streams up there, and the All Sky camera is going to go here when it's ready. And now here's the I Want Cool Pictures. You click on this, and it takes you to the online database. All right, but this is what you got to read. You select these different folders, and again, it's a manual process right now, but you get all the images we take tonight or any night for free. We give them to you. All right, it's all freebies. Hi there, Lady Astrid. I'm glad that you joined us. Make sure you join, okay? Because again, it's free. We're not asking. It's not costing you a dime. We have some of our past winners here as well, and we're going to be labeling more of them as soon as we get all the data. And so it talks about what we do, who we are, where we're located. Our home office is in Mesa, Arizona, which is where Marianne Robb, who is our CFO, is located. And then we have Tara Diulis, and she is also out there. I'm the only one that's in Connecticut, and I'm running this from Connecticut, which is kind of interesting. So basically, what we do is I've got the telescope running, and I am in Connecticut running it from here. So this stuff here is 2,600 miles away, 2,500 miles away. I just reach out and touch it.
Can I talk about light grasp a little bit?
Yeah, sure.
You got me going on it.
I did. With
when Mark talked about naked eye versus binoculars, the human eye, when it's dark adapted and at maximum opening dilation, is about 7 millimeters across. That's 280 thousandths of an inch, a little over a quarter of an inch, okay? And when you get older, your eyes may only dilate to 5 millimeters, which is about 4.4 inches. Or no, excuse me, 5 times 4 is 0.2 inches. Mm-hmm. The whole idea behind binoculars and telescopes and all that stuff is called light grasp. It's a matter of, we call it aperture, which is the clear diameter of Mark's telescope there, or the big front objective lens on your binoculars, or your naked eye. Those are all examples of aperture. When you see a pair of 7 by 50 binoculars, for instance, the 7 stands for the magnification, how much it's magnifying, looking at making things look 7 times closer than to the naked eye. And the second number, the 7 by 50, 50 is the clear aperture in millimeters, which is just a hair under 2 inches. So you see each lens in that pair of binoculars is 2 inches across versus your eye at 1/4 of an inch or so across. And by pi r squared, the area of a circle, well, the amount of light you're capturing, the light grasp, grows greatly through lenses or mirrors in telescopes or binoculars. And when you have an 8-inch telescope, well, that is a whole lot of aperture by pi r squared. If you go to a 16-inch telescope, it's getting pretty big. Well, it doesn't have twice the light grasp of an 8-inch telescope because pi r squared. 16-inch telescope will have 4 times the aperture, 4 times the light gathering power, that is, of surface area of an 8-inch telescope. So all of a sudden you're capturing large amounts of light. And going toward the telescope end of things, well, a lot of people think magnification is what it's all about. They'll get a telescope and they'll immediately put the highest power eyepiece in there, and they'll probably be disappointed when they look through it.
They sure will.
The idea primarily is not magnification, it's light grasp, how much light you're catching. The more light you catch, the fainter the things you can see, the sort of deep sky objects we look at here. Faint fuzzies, we call them. And the more light you capture, well, you can see them better. Plus the aperture with a thing called Dawes limit, the bigger the aperture, the finer the resolution of the telescope nominally. And that's how light grasp works.
Oh, thank
hey,
you,
look,
Daryl. That was very nice.
The comet's back.
Yeah, sort of. I'm taking pictures now because it's like art projects now. You know, it's like an art project. Thank you, Michael Hedrick says this is beautiful. Well, Cloverleaf says, why can't they teach this stuff in school? I'm with you 100%. You know, I was I taught astronomy for years, and I only got out of it because I got burned out of it, basically. But it's actually it's pretty cool, you know. And you know, I went to school for astronomy, and I think that astronomy is where it's at. It's only through a rigorous application of astronomy that we'll ever leave this planet someday. You know, and so it's rigorous science, right, that we are going to be, you know, having to pursue. That said, I have to say that, you know, understanding the universe is the only way we're going to find a place to go. In astronomy, my specialty was exoplanets, planets around other stars, and so I spent a lot of time learning about exoplanets, and trying to figure out what we have for stars that could support exoplanets in our galaxy. Because if our galaxy is anything to look at, then many galaxies will be like ours. The Andromeda Galaxy, our closest big galaxy to us, never mind our Magellanic Clouds and dwarf galaxy that's around us. But the large Andromeda Galaxy, whereas we have perhaps 100 billion stars at the low end, 400 billion at the high end, but that's probably not right. Our galaxy is a small fry compared to Andromeda. Andromeda's got over 1 trillion stars. Now, in 1 trillion stars, how many stars do you think there are that would be forming with planets around them? Probably the vast majority, actually, as it's turned out. As we learned in the science, we've learned that there's many more planets out there than there are stars. Now, many of those planets are around some of the fainter stars, like up in this image here, you see this little faint red star here, or this one. I'm just using these as an example. I don't know what these are. If it's directly, they could be reddened by the weather conditions. But the reddest stars are these little tiny M dwarf stars, M, like the letter M. Okay, many of them are just slightly bigger than the planet Jupiter, and they have planets around them, and those planets face their star at all times. They're tidally locked, like the moon is locked to our planet. So they're the ones that are the most plentiful stellar type in the entire universe, and they're so good at what they do. They're so good at doing nuclear fusion, fusing hydrogen into helium, that not a single one of them has died since the universe was formed, 13.8 billion years ago. They literally live trillions of years. And our sun only lives 10 billion years. So that's the interesting thing about our sun. It sort of came along well after the universe was underway. If you think about it, whole civilizations could have come and gone in the universe, and then we were born. And then the Earth was molten, and the moon was, created off the Earth. Things like that. It's amazing to think of the timeline in the universe and how there's been time of plenty. And it's a philosophical thing, but it's really good to talk about. It's a more of a cosmology topic, not an astronomy or an astrophysics topic, really. Oh, yes, we could throw astronomy in there, astrophysics in there. But we're not going to get the same, appeal, because when you do this, what you want to talk about is you want to actually try to consider that the universe being so vast and have with such a long time frame, a lot can happen in 4 billion years, right? So, it was 2 billion years ago that oxygen began percolating up from the phytoplankton and the cyanobacteria that were the first major life forms on the planet. And that oxygen started to fill an atmosphere on the early Earth, and any carbon-based being in the universe needs oxygen to survive. So, since carbon's number 4, it stands to reason that there's a lot of carbon-based beings out there. So they're going to look for a planet with oxygen on it. So it stands to reason, again, that there might be life elsewhere looking for planets with oxygen. And guess what? We've been broadcasting that for over 2 billion years. So Stephen Hawking once said we should keep our heads down. We shouldn't try to join the cosmic community out there, because we don't know what they might think of us, and they could be dangerous. And he's right. But what I will say is this. I'm going to clear this and start again. It's too late. We have been doing this and sending out a signal of oxygen in our atmosphere for over 2 billion years. So, too late. Too late, Stephen Hawking. We are noticed, and most likely the notice that they've taken of us is, wow, there's life there, and we have the technology to go there fast. Let's go there. And that's the basis of one of my lectures. It's very popular, and that is how alien spacecraft, alien craft, creatures from other worlds, if you will, intelligent species, can get here from there fast. With this technology, Alpha Centauri is 20 minutes away, not 12,000 years. I'll be doing a lecture on this at a conference here in Danbury, Connecticut, next week, and then I'm doing the Shag Harbor event next year too. As it turns out, they invited me, and I'll be talking about it there. I'll probably be at Contact in the Desert. I'll be talking about it 2 weeks from now in Phoenix, because I'm going to be out there teaching astronomy in the desert. So it's going to be a lot of fun.
Let's talk about Alpha Centauri a second.
Yeah.
I have sent you 1 or 2 videos, links to videos by a guy, I think he calls himself Professor Simon or Prof. Simon. There are stories out there that we may have discovered radio signals from outside intelligence, and they're bubbling around. It hasn't been officially published yet.
I saw that.
But this Professor Simon guy, he's a really goofy looking old English professor.
Yeah.
He looks like an escapee from a Thomas Dolby video
He really
back in the 80s. He's been touching on some details of this. He's connected with a lot of these people. This is going on over in Europe, in the EU. Mm-hmm. And the likely target, I think they said they actually have 5 possible targets, but the strongest candidate right now, I'll give you 3 guesses where the radio signal's coming from, and the first 2 don't count.
You're not talking to me, right? Because I think I know the answer.
Proxima Centauri.
Yeah, exactly.
Proxima Centauri B.
Now, Proxima Centauri is a interesting potential M dwarf star. It's one of those M stars I was telling you about. And the main components, we'll just watch the clouds go. the main components, A and B, capital A, capital B, are stars kind of like our sun, and far away from them orbits Proxima Centauri around both of them. And around Proxima are planets. Well, so far, there look like there's one certain confirmed planet. There might be a second planet. So we call that Proxima little b, okay? And that little Proxima b is an interesting planet, but there's no way to know whether the planet has an atmosphere yet. And no, just so you know, the James Webb has not seen lights on the surface. That's another story that's out there. And Daryl, you've heard those, I'm sure, too. And so it's not a planet that we know that has life. However, the signals are something we need to understand. Now, there's a possibility that they are actually cell phone signals originating here on Earth that went to satellites. And he mentions that, I believe, in his video, correct? Didn't he say that?
A possibility, yes.
Yeah. And so...
they're trying to eliminate all the mundane things they might be.
Yeah. And I will say this, okay? Our James Webb Telescope is really capable, and although it can't see lights on the surface of another planet around another star, what it can do is it can do what's called characterize the atmosphere. If Proxima b, the planet circling Proxima Centauri, the star, if Proxima b has an atmosphere, the James Webb Telescope can see it, so to speak, and it can actually likely characterize it, tell us what's in it. And it did that for another planet recently, and this planet was really quite surprising. It was amazing because what it discovered is potential life as well. And this result has to be confirmed, but every result has to be confirmed and vetted.
Absolutely.
Yeah, and so, and this find on this planet, I think it was, is it Kepler 21b? I could be wrong about that. It's a Kepler object, okay, and in this planet's atmosphere, it saw methane, it saw carbon dioxide, okay, and it saw other hydrocarbon compounds, but it also saw a compound called dimethyl sulfide. Now, dimethyl sulfide, I mean, you just walk by it and you go, what the heck is that? I don't even know what that is. If you know anything about chemistry, organic chemistry in particular, you know that dimethyl sulfide here on Earth, in fact, almost everywhere else, as far as we can tell, dimethyl sulfide is only made by life. And you know it on Earth. Every one of you listening knows what dimethyl sulfide is. You just don't realize it. Dimethyl sulfide is the smell of the sea. When you go down at low tide, that stink, that's dimethyl sulfide. And this planet has two very interesting signatures that are right smack dab on the dimethyl sulfide compound lines. And so if that's there, it means there's life, and that James Webb found life like 8 months ago. They're going to confirm. Now, that said, one other thing that's really cool, all right, that I'll share with you, is that planet is not like a planet like Earth that has a blue sky and oxygen in the atmosphere, okay, and so forth. It's not. Its atmosphere is hydrogen gas, all hydrogen, with some impurities. So it's called a Hycean world, Hycean, a Hycean world meaning hydrogen-based world. And it also appears to be a water planet. Remember Kevin Costner's movie Waterworld?
Oh God, Mad Max on jet skis.
Yeah, right. Okay.
What it was.
Well, the Waterworld concept was that the oceans on Earth would rise and cover everything. As it turns out, that's not true. But in this Hycean world that the James Webb discovered, if there, I think this is getting a view back here. If if this hydrogen atmosphere, notwithstanding, is there, and we see dimethyl sulfide, it means that life is there, and it looks as if we're looking at a planet that's entirely water covered so far. That's at least based on the chemical analysis of that atmosphere from the James Webb. Now, is that for sure, or is there islands? There could be islands. I don't know. I mean, I would think that most planets of that nature will have plate tectonics and have bump ups, and you get land masses, maybe temporarily. Who knows? But it's a hydrogen world, and a hydrogen world, hydrogen atmosphere anyway. Well, it's kind of problematic because that doesn't work for us. You know.
Can I give you something to think about?
Sure.
Imagine if that radio signal from Proxima Centauri b is real. Just think that, well, here we are on planet Earth going around a pretty everyday star, and if it turned out that the closest star to us, 4 light years away, also had life, what does that say about the probability of life in the larger universe? It would seem to say that, gosh, it's darn likely. Not a coincidence among billions and billions of stars.
That's very true. Very true. That bright streak you saw going across right here, guys, that was a satellite that went through. Yeah, and that's the thing. And you know, in the book that I wrote called The Populated Universe, I make the argument for life in the universe is the rule, not the exception, based on analysis of DNA structures here on Earth, based on the symmetry of life itself. Every single life form has symmetry on this planet, probably based on DNA and how it replicates. Every single life form also has a strange quality that we have, and might be a universal template, just like DNA is probably a universal template because every life form has it. And that quality that they may have is a characteristic of their personalities, if you call them that. And that characteristic is curiosity. Every creature on the planet is curious. Even at the microbial level, microbes seem to be interested in things and they go to them. Now, yes, they could be driven by things like food, eat, but at its base most emotion, we think about the base most driving force is a curiosity that comes out of in fact, you have to have curiosity so that you can go hunting for food. Is there something over here? Is there something over there? If you didn't care, you wouldn't look and you'd starve to death. No food came to me, you know. But the point is, a creature that has curiosity will actually end up looking for food and will look for other things and find things along the way and say, ooh, what's that? No, not a microbe, but a dog, okay, cats. They see something, they walk up and they smell it. What's that? You know, and they play with it and then they walk away. So there's all kinds of possibilities, and a lot of it depends on how they're wired, how alien creatures are wired, and we don't know anything about that. We can't assign our morality to them. If they come here as scientists, they're going to be curious. They want to find life like them. They're probably carbon-based. I'm a carbon bigot, I admit it. And if they're carbon-based, they're going to come here because we're displaying life for billions of years in our atmosphere with oxygen. So they'll check us out and say, "Oh, let's check out these creatures." You know, Torg, give me that probe device. Next thing you know, you got a story to tell, and it ain't a pretty one. See, we think we're the intelligent species on the planet, but there's other species out there that may very well be thousands of years, millions of years ahead of us. So they're going to have already figured out what we're only just figuring out. How to...
So long, and thanks for all the fish.
That's right. Hitchhiker's Guide to the Galaxy.
Yeah, they took the dolphins and left us here. Michael H. has a question for you, Mark. He's probably a little above the top of the chat right now.
I see him.
I would like to chime in on this if you choose to answer.
Yeah, is that the one where it says, do you think any life could survive the
Yes.
the radiation levels of Jupiter's moons? And could anything cope with that level? That's a good question. Let's look at evolution on the planet Earth. Okay, I'll speak about Jupiter in a second, and Daryl wants to say something. First of all, to go into the deep ocean here, we could never survive in the deep ocean where, for instance, a Titan imploded, okay? Horrible thing. But there are fish at that bottom that swimming around and doing their thing. Why do they survive there? Because they evolved there. They evolved there. They didn't drift down from above and say, oh, this is high pressure, but I can stand it. No, they evolved there. And the thing is, if you take them out of that, if you go to midwater, in other words, not from the bottom, but go halfway up to the surface, the midwater, it's called, well, they'll explode because the pressure on them is now much reduced and they can't survive at higher levels in the ocean. So depending on where you evolve, you can actually probably evolve to anything as long as the radiation, just like you were mentioning, isn't powerful enough to break the carbon bonds and attack the DNA within the cells that hold the bonds together. Okay, and that's the problem that we see with Jupiter's radiation belts. Now, Earth has radiation belts as well, but Jupiter's are like 20 times the size of ours. The massive, the strength, and the reason is because it's actually Jupiter's magnetic field, just like it's Earth's magnetic field, trapping solar particles, the solar wind. And that solar wind coming into our magnetic sheath, our geomagnetic, or our magnetosphere, those particles are getting trapped in our magnetic field because they're charged and they're following the magnetic field. And those become what we call our radiation belts, the Van Allen belts. Jupiter's are that much larger, and so the solar flux is getting trapped there too, and then orbits Jupiter and stuck in the magnetosphere of Jupiter, making those deadly radiation belts. Now, to survive those, we figured out with spacecraft going out to Jupiter now that all we have to do is put them in an aluminum vault about that thick. You put them in a box about that thick, okay, an 1/8 inch of aluminum, maybe a little more, and you make a box and put all your sensitive electronics in there, and you'll survive Jupiter's radiation belts.
I think they said 1/3 of an inch.
1/3 of an inch? Okay.
Yeah.
Yeah.
Marianne is here, by the way. Hello, Marianne.
Hey, Marianne. Yeah, we're trying to look at the comet, Marianne. It's getting really low to the horizon. We did.
Can I?
Yeah, go ahead. Daryl wanted to say some things about this as well.
Michael, one thing to consider, a substance that stops radiation quite well, I assume, that being carried by radio waves or, magnetic waves, electromagnetic waves, is water. And that's one reason that Europa is considered, it's a water world covered in ice. Europa actually has more water on it than in all of Earth's oceans. And therefore, where we need shielding to survive in a Jovian environment, that could be a natural place, again, for life to evolve.
That's right, yeah. That was the other thing about Europa that makes Europa so attractive, as Daryl just said. So that's something interesting that would preserve any life underneath the European ice sheath on top. Now, that ice in the sheath is water ice, okay? And there might be other ices in there because obviously the surface is very, very cold. But that sheath is also miles thick. The ice on Europa is miles thick, okay? Makes our Antarctic ice sheets look like a piker, a beginner. And so, but there's deep fissures too, and that's the way in to the ice sheath. And you're gonna have to go through these fissures, and I don't know how we're gonna get to the inside of Europa. I really don't, because I know they talked about submarines and drilling. I think that'll fail because I think that they don't realize just how deep these fissures go. I think it's more like a slush for a long way until it actually becomes water, and then when it becomes water, it's going to be very briny and salty. By the nature of the development we see and the nature of the chemistry that's exuding from geysers on Europa, just like Enceladus at Saturn, it's possible that microbial life could form there. And it's very cold at the surface layers. But because Europa is being kneaded, as in Kneaded, like bread, kneaded like bread by Saturn's other moons and Jupiter's gravity as well, it's literally flexing Europa every time it's orbiting, all the moons and the interactions. And that heats up the core of Europa tremendously and has helped to keep it warm for billions of years. So it's likely that that 2,000 mile diameter moon, it could be 60 mile, 90 mile deep ocean underneath all that. And in that space, you could be 40 miles down and the water pressure wouldn't be anything like on Earth. Okay, it'd be less because Europa's so much smaller, and the temperature might be a nice 70 degrees Fahrenheit at that depth. You know, for all we know, I'm making those numbers up because I don't know exactly, but we can figure that all out depending on the geothermal qualities within Europa. But the point I'm making is that for life as we know it, there's places within the European Ocean that we can reach where that will be capable, very, very, very possible. And so that's something that has attracted everybody to Europa.
Along the lines of all this, I may have mentioned this before. Kurzgesagt did a recent episode on YouTube saying that there is more life beneath the surface of our planet than there is on the surface and in all the oceans underground. And they get into the details of it, life and extremophiles and all this stuff. That, yeah, it's down under us, and there's more of it down there than there is up here. And they follow that line of thought and carried it out to Europa and other moons of Jupiter and Saturn and places. If I remember correctly, they said there were like 9 or 10 candidate planets or moons other than Earth in our solar system that could very well be carrying life.
Yeah.
And so again, you know, we're just talking about how common life might really be.
Yeah. That label that just came up is not what this is, guys. This is Messier 11 in Scutum. And I brought it up to do some focusing. And once we're done focusing, we'll center it up, take a shot. Because if you look at our all-sky, the location where the comet is clouded out. But we have a pretty good spot right here. And that's kind of where we're looking right now. So that's what we'll do. And I can actually get us back to our so this guy right here, the home page. There we go. See a little better.
I see Altair and Terra Z and Vega and Deneb and Satyr and Alberio.
Yep, they're all there.
There's Altair, and where you're looking is down close to Altair,
Yeah,
a little
down
farther down. Yeah, Scutum.
Yeah, you can just barely see the Milky Way even with the moon out. So we come out of this, and we got our focus, and we are focused. So I can get out of this right now, and then I will slide this over a little bit. I'm going to head west with this a little bit. So, so the other reason that Europa became attractive to us is because in the 70s, the Alvin submersible, and I did a talk for the Alvin engineering team, the Alvin submersible went down to the bottom of off the Juan de Fuca Ridge and off the Mid-Atlantic Ridge as well, and discovered these sulfide chimneys, which were these what they called black smokers at the time, these black chimneys, and they were spewing this 900-degree mineral-laden water. And what they discovered is that bacteria loved to feed on that hot water, these extremophiles Daryl was mentioning. Those extremophiles then fed other creatures, which fed on them. And then those creatures were fed on by more creatures. And so an entire ecosystem forms around these hot spots coming up from the Earth's mantle, where this black mineral-laden water comes spewing out. Now the ocean's obviously got a lot of mass to it, so it percolates down into the bottom, gets way deep, almost to the mantle, and then starts percolating back up through fissures. So it's pushed down, then percolates back up when it gets really hot. Okay, because hot water rises within cold water. And so when that happens, we see this stuff spewing out of these chimneys. And as the Earth's tectonic plates move, okay, the hot spot is coming up underneath, and as the Earth's plate moves, the hot spot is also moving on the bottom of the ocean. So when you look at the bottom of the ocean at these sulfide chimneys, these hydrothermal vents as they're called, you see that there's a chain of ones that are dead long ago, and then you have the active one. And that tells you immediately which way the plate's moving, because you can see the oldest one is down that end, and the newest one's right here. So the plate obviously is going this way, right? It's going that way. So you get the new plate and a new hotspot and a new vent. So, okay, seeing that life down at the ocean floor, we know it's not doing photosynthesis because we need the sun for that. That's what plankton does. So how are all these creatures living? They're living through chemosynthesis. And chemosynthetic processes are the thing that we thought, hey, that means if there's chemosynthesis going on here, maybe it's happening on Europa. And as it turns out, the Cassini probe at Saturn found hydrothermal vents beneath the Enceladin southern pole. So even on Enceladus, there's hydrothermal vents confirmed. We haven't confirmed them on Europa yet, but we see the evidence of it. So the evidence of the possibility. So that's kind of cool. And so it's that. And then the thing that cinched the deal for a lot of people was back when the drilling project in in Antarctica at the South Pole, they were drilling down to Lake Vostok. There's a lake that's been hidden for millions of years under miles, a mile and a half, 2 miles of ice. And deep underneath that ice, there's a lake. They could see it from the ground penetrating radar. And this lake, as they thought, might be a barren lake, just empty water, whatever, but maybe there's life in it. They drilled down into this lake, and when they got to the lake, they discovered no less than 3,500 different species actively taking place, reproducing, dying, starting a chain. No, go away, clouds. Starting a chain of life with cycles, the carbon cycle, okay, the other cycles, the methane cycle going on underwater that feeds back into the system, and it made it a closed loop system. And that, coupled with the hydrothermal vents in our oceans, made people think that maybe there's a lot of life underground that we don't know about. And maybe at, for instance, Europa, we'll find a lot more of it. So there, see, while waiting for clouds, we saw that. We talked about that. And oh, by the way, the Europa spacecraft, the Europa Clipper, just took off successfully. And is on its way to Europa right now as we speak. I can't wait for that.
Michael H. has yet another question for you.
All right. Oh, we're going to have these clouds for a while, so I can't look at M11. Okay, what's he say? Where are we? Oh, thank you for putting up the links, by the way.
What estimates would you choose for a lander on another world? What would be most helpful, you think?
Oh, interesting question. You want to go first?
You're on a roll. Go ahead.
Okay, well, in my view, I would actually put that out to a university competition to find the best way to have a mobility, a vehicle that could go in any direction. It depends where you're going to. If you're going to Mars, then the rovers like Perseverance and Curiosity have been just by far highly successful. The wheels, the harshness of the Martian terrain with the cold has affected those wheels negatively over time. Curiosity is still rolling, has one frozen wheel, I think, at this point, but all the other 5 are working great. And Perseverance is working great. And they also put a helicopter on Mars with the Perseverance rover. And that is another thing. You know, do you go in the air if there's an atmosphere, or do you just go on the ground? If we're going to Europa, you can't just go on the surface of the ice. That's a thing to do. But you want to know what's underneath. So you're gonna want to drill down into the ice. You're gonna have a way to have a way to do that. One of the ways I think is the best way is to not actually drill like with a drill, but to use heat. And I think that a heat drill would be the best way to do it. And the entire lander, the bottom of the lander would be like a cone, and it would just slowly subside into the ice as it's generating heat. Now, how would it do that? It would have a nuclear reactor on board, but that's okay. We're using those now. They're called RTGs, radioisotope thermal generators. They actually generate all the power needed for a craft, and they keep the components warm. And RTGs have been in use for decades. So we could use those. Curiosity had one. All right. Perseverance has one. Okay. So this is the way to get power on a planet. Now, those generators don't last forever. The fuel does run out. But if you can generate something where you can actually melt a hole in the ice and just melt yourself down while leaving a system on the surface to communicate back to us, because once it's in there, the ice, you're not going to get a radio signal out of there. So that'd be pretty cool. That'd be the way to do it. Bonnie's here. Hi, Bonnie.
Back when we launched the Viking landers, the first touchdown on Mars, the instrumentation, one of the instruments on the Viking, when it ran some primitive tests for possible life. I can't tell you the particulars, some sort of a chemical thing. It had such a strong reaction, saying possibility of life, that they wound up discounting it. They thought, that I don't know what they thought. It was such a strong response that they figured it had to be purely chemical and not a sign of life.
Yeah.
Maybe that was just a bad choice of instrument, but there you go.
I remember that. There was a very interesting story about the Viking oven. It was a soil baking experiment that Daryl's talking about. I have upstairs. I have the entire. It's a nerd thing. Entire scientific results study from Viking. It's a gigantic book. That's a massive book full of all these scientific experiments, which is really cool. So in there, it talks about this particular experiment and and why they discounted it. And as Daryl said, discounting it was like the wrong thing to do, but it's almost like because they never expected to find life, they chose to ignore life, potentially. And that's not good. There you can see the clouds. We're down on the ground looking up at the telescope. So that's what we got out there. I'm just showing
as ever, I bring this up a lot. Well, golly, what if we land some sort of a nuclear thermal drill on Europa? Or what if we land on Mars? Or, as Lubo says, what if we release a balloon in Jupiter's atmosphere? What if there is life? And what if we kill it? Do we have the moral stature to refrain from killing off life on another planet?
And that's very true. That's actually a very true dilemma. Yeah, very true. So, guys, obviously, you can see that with the clouds here, we're not going to be able to go any further. So, excuse me, the Comet is set. So, we are done for tonight. But we're having good discussion. So, I'm showing you this so you can actually see the shutdown process. So, I'm going to shut off the telescope now. This is the program that I wrote to control the telescope and the building. And then I'll shut the roof now. You'll watch the roof close.
Oh, don't forget Tiffany before you end the stream.
I'm not forgetting Tiffany. That's the last thing we're going to do. Hopefully she didn't fall asleep or something. Okay, telescope's disconnected. And let me now go look and see if Tiffany is ready. So if you guys are okay, here we go. Okay, Tiffany, we're ready if you are. Evan B. Daniels just wrote a message. Make sure he gets entered. Lubo in China joined us. Alice Pooper did. Oh, here we go. The winner is. Let's find out. Now, she's done a raffle of all the names of the people that took the time to write in the chat. So let's see who it is. Hey! Giancarlo Belfry. You are the winner of the Celestron binoculars. There you go. Your name was drawn completely at random by Tiffany Echo. And you are now the owner of a new set of binoculars, courtesy of SkyTour Livestream and Tiffany and Michael.
Way to go, Giancarlo.
That's a great name. One of my favorite actors is Giancarlo Esposito.
Oh, yeah. Gus Fring.
I like him, yeah.
Yeah. He was in one of the Mandalorians, too.
Oh, yeah.
He played a bad guy.
Yeah.
Actually, I've seen him play bad guys in several shows.
He plays
Good, he's still working.
He plays bad guys in computer games, too.
Yeah.
This is kind of funny. Far Cry 6, he's a bad guy. This is kind of interesting. Pause and Portraits, thank you for congratulating our buddy Giancarlo. Okay, Giancarlo. Now the work begins. You have to go to SkyTourLive.org, and when you get there, you need to go in and go to a link, which I'm going to show you. Here is SkyTourLive.org. There I am down the bottom high. Okay, you're going to come here, and you're going to go up here, go to email us, and send a message with all of your information and your shipping address. And we would like to send you this wonderful pair of binoculars courtesy of SkyTour Livestream, Tiffany Echo, and Michael Tarr, who are our giveaway, what do we call them? Divas? No, they're not divas. Champions. They're giveaway patrons. They're just fantastic people. Yeah. So I'm glad you like it. He says, yay. Yeah. So do that if you will, Giancarlo. Go here. Go to SkyTourLivestream.org or SkyTourLive.com or SkyTourLive.org. All right. And go to email us and let us know all of your address details, and we shall send you the binoculars. And congratulations, Giancarlo. Welcome to SkyTour Livestream. That's a hell of a welcome, isn't it?
Ta-da.
Just show up and boom, win something. That's kind of cool.
Yeah. It's a drawing, not a raffle. Raffles cost money.
Oh, I guess that's true. So, stickler, you know.
You know me, I'm a grammar Nazi.
Yeah, well.
Well, thanks for having me on, Mark.
Yep, it was great. And I hope you have a good night, Daryl. And, folks, we will we will see you at a later time, you know. So hopefully you guys enjoyed tonight. We did get a little look at the comet. We also did, as a matter of fact, manage to get some photos that I saved and have up there, so we're good. Check them out. Have a good night. And Tiffany, thank you again for doing this birthday drawing for me and everybody on our chat tonight. That was very nice. And a surprise. I didn't know it was going to happen, and when I found out, I was like, that's so cool. But that's our Tiffany Echo. All right, guys. Thank you so much, and we will see you on the next clear night, because I am planning on catching this comet every night we can. All right? So you have a good evening, and we will talk to you soon.
Happy trails to you until we meet again. Good night, everybody.
Good night, folks. See you later.
Stars so bright in the sky, on Arizona nights they fly. Nebulae in colors rare, galaxies beyond compare. Sky tour in the night so clear, brings the universe near. Real-time wonders to see, streaming light for you and me. Lift your eyes to the skies, universe in all its light. Sky tours bringing the views. Every night feels brand new. In the dark, the night unfolds, stories of the cosmos told. Through the lens, a distant dream, living real like a gleam. Far away, up so high, across the stars beyond the skull. Through the lens, a distant dream, living real like a gleam. Lift your eye up so high, across the stars beyond the sky. Sky tour shows us the way, every night a new display. Lift your eyes to the skies, universe in all its light. Sky tours bringing the views. Every night feels brand new. Lift your eyes to the skies, universe in all its light. Sky tours bringing the view.